This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Hello, this is Matthew Farwell for Software Engineering Radio. Today's episode is about WebAssembly with Lynn Clark. Lynn Clark makes code cartoons. She's also part of Mozilla's Emerging Technologies group, where she works with the WebAssembly and Rust teams. Her current project is making it easy to use WebAssembly with today's JavaScript tools, including NPM and bundlers. In previous lives, she worked at NPM, and she was a core contributor to open source projects like Firefox's developer tools and contributed to HTML data standards. Welcome to Software Engineering Radio, Lynn.
Thank you so much for inviting me to be on here.
Okay, today we're going to talk about WebAssembly. We've covered web application development with JavaScript in the past. For instance, in episode 293, Yakov Fein on Angular. WebAssembly is a new technology for creating web applications. So Lynn, what are the goals of WebAssembly?
Well, one of the big goals of WebAssembly is to make it possible to have consistent performance in your applications. So, traditionally you have three languages that you use when you're building a web page. You have HTML for giving the structure to the page, you have CSS for styling it, and then you have JavaScript for adding behaviors.
Okay.
And, if you want to have an application that runs performantly, in JavaScript, you can do that for most web applications. But it can sometimes, JavaScript wasn't really designed to be fast. It was designed to be easy to get up and running with it quickly. And there are some things in JavaScript that make it hard for the browsers to actually run JavaScript quickly. So what WebAssembly does is give you a language that can do a lot of the same things as JavaScript, that can give you those behaviors on your page, that interactivity, but can do so in a more consistently performant way. And the way that it does this is by giving the programmer a little bit more control over exactly how the code runs. So, for example, how your code works with memory.
Okay. So what are the target use cases then, if you're saying it's a performance-based thing?
The original target use case, the first one that we worked on, was for PC games. Because when you're playing PC games, if you were to have a PC game that used JavaScript, you might have GC pauses, you might have places where the code was a little bit inefficient, and so you'd have that game dropping frames. So you'd have gaps in the animation. It would really kind of take you out of the experience of playing that game. So WebAssembly, we originally partnered with game companies like Unity, the Unreal Engine, those kinds of game development tools, so that they could target the web as a platform.
Okay, so is it just for visualization, or is it for other things as well?
That was the original use case, but now you're seeing it being used in other use cases as well. So for example, Adobe has their Lightroom product, which can run on the web. It's an image editor. AutoCAD has a lightweight CAD editor that can run on the web. I think it's called Formit. So you're seeing these kinds of applications that you would previously have to install directly on your computer. Now it's possible to run them in the browser itself, so that you don't need to install anything. You can just download it on the web right there from the URL, and it'll be there in your browser. We also are seeing some other use cases. For example, the source map library that's used in tools like Webpack. One of the maintainer of that is on our team at Mozilla, and he decided to take the parsing and querying part of the source map library and convert that to WebAssembly from JavaScript. He saw a 6 times speed increase for that part of the code. Ember is also working with taking the bytecode interpreter they have, the Glimmer bytecode interpreter that they've been working on, and rewriting that in Rust that will compile to WebAssembly. And so it's both these applications, these full-fledged applications that would normally be developed in languages like C and C++, and also these smaller parts of applications where you can see the performance improvements from WebAssembly.
Okay, so that's a good question. Who is behind WebAssembly? Who's pushing it?
all 4 browser vendors have gotten on board. We started this thing called Azam Jas at Mozilla in 2012 or so. And that was the seed of this idea. But the folks that were behind Azam Jas, in particular one that I work with a lot, Luke Wagner, did a really good job of getting other people on board. At the same time, Google had this project called Pinnacle that had a lot of the same aims. And so through meetings with Google and with other companies, Microsoft and with the JSC team at Apple, they were able to come up with a common vision. And that's really how WebAssembly started, is this common vision across all of the browsers for how you can have this more consistently performant code that runs on the web.
Okay, so as I understand it, WebAssembly was based on Azam.js. Mm-hmm. Could you explain a bit more about Azam.js and a little bit about the history?
Sure. Azam.js kind of has an interesting history. So we had an engineer at Mozilla who had come up with this tool called Emscripten, which you could use to take code that was written in C or C++ and compile it to JavaScript. But that code ran really slowly. So we had folks at Mozilla that wanted to make it run faster. They put together some engineers in a room. Luke has a great story about how when he first looked at what Emscripten was doing, he said, there's no way you can make this fast. But then came up with this idea for how you could have a little signal to the JavaScript engine, what types it was working with. And with that, you could make Azam.js, the code that this Emscripten compiler was spitting out, you could actually make it possible to optimize it in the JavaScript engine. So really, Azam.js was just a strict subset of JavaScript that used a couple of kind of weird conventions to make it possible for the engine to run that JavaScript quickly. And it wasn't until they started working on WebAssembly that you moved to something that wasn't actually JavaScript.
Okay, so if I understand you correctly, Azam.js is a subset of JavaScript, which is can be seen by the compiler in Firefox, and it picks it up and runs it fast.
Exactly.
Okay. So the question is, why do we need WebAssembly? Why can't we just make JavaScript faster? What? Well,
there are certain things about JavaScript that do make it hard to make it fast. The dynamic types that you have in JavaScript can make it really hard to make JavaScript engines faster. And there are only so many shortcuts that you can add to a JavaScript engine. There's only so many hacks. Another problem is that even if you optimize to a particular JavaScript engine, because these are all heuristics and hacks and everything that you're putting into the JavaScript engine to make the code run fast, if you optimize to one JavaScript engine, it could de-optimize your code for a different engine. So it'll run slower in a different engine. WebAssembly, you're going to have more consistent performance, not just across your application running in one browser. You're also going to have more consistent performance across all of the browsers.
So what exactly is WebAssembly?
What is it? It is I talk about it as if it's a language, but really it's more of a compiler target. So when you're working with WebAssembly, you're going to be writing in a language like C or C++ or Rust that compiles to WebAssembly. WebAssembly gives you, a small set of operations like you would have with an assembly language. It gives you this small set of operations that, your higher level language can compile to. But it's not actually an assembly language because it's not targeting a particular physical machine. It's not targeting, x86 or anything like that. It is targeting a conceptual machine. When it gets shipped down to the browser, the browser takes it from this slightly higher level assembly down to the actual assembly for whatever machine it's running on.
Okay, so it's similar to Java bytecode.
In a way, yes.
Okay, so does that mean that there's a virtual machine inside Firefox or in Chrome?
Exactly. It's actually using the same VM as the JavaScript engine. It is in the JavaScript engine, implemented in the JavaScript engine.
Okay, so WebAssembly is kind of an assembly language. So do I need to write in the assembly language? You mentioned C or C++ earlier on. Can I write in C or C++?
You can write in the assembly language if you want to. Just like other assembly languages, you can write in them if you want to. Very, very few people actually want to handwrite their assembly. So most people are going to be using a compiler toolchain that compiles to WebAssembly. Right now, that usually means C, C++, or Rust. That's because those languages for the WebAssembly MVP, the WebAssembly that's in browsers right now, they're more well suited to it because the WebAssembly MVP didn't have garbage collection support.
Okay.
So you want to have languages that, like C and C++, where you're manually managing your memory yourself using malloc and free, or Rust has these concepts of ownership and borrowing that make it so that the language can help you clean up after yourself. But either way, neither of them require garbage collection. We are accelerating the garbage collection proposal through the WebAssembly standards group. So soon you will be able to integrate and interop with the browser's built-in garbage collection. And that'll open doors to a whole bunch of other languages, make it so that they can work with WebAssembly in an optimal way. Because right now you can ship down your own garbage collector, but that's inefficient for a number of reasons. You're adding bytes to your WASM file. It's running slightly slower than it would be. The built-in GC that you have in browsers has just been so highly tuned and optimized that really it makes a lot more sense just to use that built-in browser GC.
I have no desire to write a garbage collector.
Understandably.
Okay, so I'm slightly confused about what we actually do to use WebAssembly. So if I were to use, let's imagine, do I need to write a main function or?
Good question. So what you get when you compile WebAssembly is you get a .wasm file, and that gives you a module. So when you're working with WebAssembly, you're always working with modules. And those modules provide functions. They provide functions that JavaScript code can use and that WebAssembly code can use. So JavaScript actually boots up your WebAssembly for you. Right now, we only have, for creating these modules, you have to use an imperative JavaScript API to actually fetch the file, instantiate it, give it its imports, that kind of stuff. We are working on making it so that you can have a declarative module API. You can use a declarative module API like JavaScript's ES module. In fact, the same API as JavaScript's ES module API. And then you'll be able to use WebAssembly modules and JavaScript modules in the same module graph easily, as if the WebAssembly were JavaScript. But for now, what you're doing is you're booting up this module in your JavaScript and then using JavaScript to control the call functions from WebAssembly, that kind of stuff.
Okay, so effectively your functions are declared are available from JavaScript, and the JavaScript engine just makes them available.
So if you export them, yes.
Yeah. Okay. So what can I do in a function? Let's take an example for our hello world. I want to do a printf. No, let's make it a bit simpler than that. I just want to return a string. Can I return a string and it's available in JavaScript?
So that does get a little tricky right now. The only types that WebAssembly understands natively are integers and floats. And so you can't really pass strings back and forth between JavaScript and WebAssembly. What you have to do is, if you have a string, let's say that you wanted to pass a string from JavaScript into WebAssembly, you would take that string and use the text encoder API to convert the string into numbers. And then you would put those numbers into WebAssembly's memory object. So this memory object, it basically emulates a heap. You can put bytes into it. It's an array buffer. JavaScript has this concept of an array buffer, which is an array of bytes. So you put those numbers into this array, and then you pass the index of the first character over to WebAssembly as if it were a pointer.
Okay.
So that's how you work with WebAssembly's basically passing in more complex types currently. There are proposals to make this easier, and there are also tools that make this easier. So one of the tools that we're working on is called Wasm BindGen, and that will wrap your code. It will take a look at what your signature is, and it will wrap your WebAssembly function with JavaScript code that can actually do take the bytes, put them into memory for you, or encode the string put the bytes into memory, pass the pointer, do all that for you. Right now, that is specific to Rust, but it's architected in a way where we'd be able to add support for other languages like C and C++.
Does that, just as an aside, does that imply that you need a static type? Do you need a type definition?
Yes.
Okay.
Yes. Basically, one of the things about WebAssembly that makes it different from JavaScript is that you are working with static types. And so that makes it so that the engine doesn't have to guess at your types and doesn't have to monitor your code to see what types you're using and then make guesses, possibly wrong guesses about what those types are.
So it's very much a C or a C++ model, not a JavaScript model.
Exactly.
Okay. Another interesting question would be, okay, so I mentioned printf earlier on. Okay, so do I need to write all my own functions? So imagine I wanted to take the power of two numbers. Mm-hmm. Where does that power function come from?
So one of the proposals that is in the works right now is called the host bindings proposal, and that would make it possible for you to basically work with DOM objects. And if you have anything, a JavaScript object or a DOM object where you can call a method on it that would do that kind of work, you'll be able to call those directly from WebAssembly. Right now, you can't do that directly. You can pass in functions that can do that. You can pass in JavaScript functions that can do whatever you need to do, but you can't call the DOM objects methods directly from WebAssembly.
Could you just explain quickly what the DOM is?
Sure. So the DOM are the set of objects in the browser that represent everything on a web page. So a paragraph will have a DOM object. A div will have a DOM object. But you also have other APIs that are available via DOM objects. So the math object. Those will be available directly to WebAssembly eventually.
Eventually, but not at the minute. You have to do some mucking around.
Wiring up.
Okay.
Yeah.
So does that apply to, let's call them system calls, because I don't know how you would describe that. So for instance, things which talk to the network.
So one example that I think of a lot is a file system. And the reason why that one is particularly interesting is because you really don't want your browser to have direct access to the file system. So in those cases, you can use libraries that will emulate. So for the file system, you can emulate a file system in IndexedDB in the browser. Emscripten will help with that. If you're using code in C that requires the file system, you can basically use Emscripten to add some code to emulate that.
Okay, so, it's another interesting question is how much of a sandbox do we have? Are you in a sandbox when you're talking?
Yes, you're in basically the same sandbox that you're in for JavaScript. That's one of the neat things about using the JavaScript engine, using this existing VM, is that VM has been really hardened because it's one of the most attacked pieces of code that we have. And so by running WebAssembly in that same VM, we're getting a lot of the same protections, a lot of the same thought that's been put into JavaScript's security will then apply to WebAssembly.
Okay, can I use third-party libraries like Boost, for instance?
I'm not familiar with Boost.
Boost is a C or a C++ library, I'm not quite sure which, standard library functions, for instance.
To be honest, I don't know on that one.
Okay. You mentioned malloc and free. Could you explain what that is and how you would use them in the context of WebAssembly?
Sure. When you're working with a C or C++, you're going to be actually managing your memory yourself. You're going to be allocating memory, and then when you're done with it, you're going to free that memory. The way that works for WebAssembly is you're allocating memory inside of that array buffer, that memory object. And then you're freeing the memory inside of that array buffer. But having it limited to that array buffer is actually pretty nice because it gives you isolation between different modules. So if a different module is, doesn't know what it's doing as far as it's mallocing and freeing, it's not going to impact your module. It will stay in its own little box of memory. And there are some security considerations around that too that make the WebAssembly memory a lot more secure than most people think would be.
Okay, we'll do security on it in a minute. I'm going to come on to that. Just to clarify, so each module has its own sandbox, let's call it.
Yeah, basically each module gets its own memory. There is some vision in the future that you would be able to share memories between modules, but that's not currently part of the spec.
Okay, can I allocate a lot of memory in that module?
So when you're setting up your WebAssembly module, you say how many pages of memory you want in your memory object. And you can grow that memory object later if you need more memory.
So you could theoretically just get more and more and more and more and more.
Mm-hmm. Okay,
so when you say pages, do you mean an operating system level page or a web page for the allocation of malware?
For the allocation, when you're saying how large you want your memory object to be, that is specified. I think it's 64 kilobytes or something like that. It's a pretty granular level. And you just say how many of those you want how big you want your array buffer to be based on that size.
Is that fixed?
The size of a single page is fixed, but you can say how many pages you want. So multiples of that amount.
Okay, so let's move on to how you interact with the browser. Do I have access to the DOM from WebAssembly?
No, you don't yet, but we are working on the host bindings proposal that I mentioned before.
Okay.
Will give you that direct DOM access. So that will make it possible for you to create and pass around and manipulate these DOM objects from WebAssembly directly.
But I have to if I want them to be manipulated, then I have to pass them in.
For now. Once the host bindings proposal is there, you'll be able to create them within WebAssembly. To be honest, I am not as involved in that proposal as I am in other proposals, so I don't know the exact future of it. But at least from what their plans are, you would be able to create a DOM object in your WebAssembly code.
But surely that means that if your WebAssembly module can access that DOM object, or do you have to Do you have to physically copy the bytes over into the memory for the for the module?
No, you don't. There are these things called tables that can hold references. There's a proposal going through right now that the host bindings proposal depends on called any reference that would allow you to have references to objects that are not inside your linear memory.
Okay, so I can access that memory, but I can't overwrite it.
Exactly. Yeah, you can get a pointer to that object, but you can't actually write a new memory address for it or anything like that.
So to recap, if I want my WebAssembly module to access something which is outside of its memory, then I need to copy it into one of these tables.
It's not as far as I understand, it's not a copy operation, but yeah, you get a pointer that's put in the table, yeah.
So theoretically, I can escape my sandbox.
You wouldn't really be escaping the sandbox. It would only be giving you the same access that JavaScript has to those objects.
Okay.
Because the WebAssembly can't actually see the values in those tables. It can just say, I want to use the object that's in this array index of the table.
Oh, okay, right. And how do I access the network? Can I make AJAX calls, for instance?
Not directly from WebAssembly at the moment. So the Fetch API is what a lot of people are using right now. Once we have the direct access to the DOM, you can use the Fetch API in the way that you'd be able to use other APIs. But at the moment, WebAssembly is fairly limited in that it can't actually reach out to those APIs.
And you mentioned earlier on about creating garbage collectible objects. That's on the roadmap, but it's not exactly possible at the minute.
Right, yeah.
Okay. Can I do multi-threading? Can I do parallel operations?
Right. The multi-threading story it's a little bit more of a complicated topic than it was expected to be. That's because we wanted to have shared memory multi-threading. So where you have multiple threads that are sharing the same bit of memory. And this was going to be possible and fairly straightforward using shared array buffers. But unfortunately, because of Spectre, we had to disable shared array buffers in all of the browsers, not just Firefox, but all of them have. We're optimistic that we're going to be able to turn shared array buffers back on in the browsers, that we'll be able to find a mitigation for the security concerns around them. And once that happens, it should be pretty straightforward to introduce support for shared memory multi-threading. But because a lot of the work has actually already been done for that before we knew that we had to turn off shared array buffers. But it will depend on getting those turned back on.
Spectre is
Spectre is this bug that Meltdown and Spectre are the big bugs that came out in January that processors have, where their speculation basically made it possible for you to access parts of memory that you really theoretically should not have access to. And shared array buffers, so it's called a timing attack. And shared array buffers could be used to create a timer that could assist this timing attack.
Okay.
A high resolution timer is what they're called.
Okay, so can I use other JavaScript libraries? Can I do calls from WebAssembly back into the JavaScript?
So you can pass in functions. There are these things called function imports. You can pass in functions from JavaScript and then call those JavaScript functions. But that's one of those cases where you actually need to know what you want to call. You need to know what you're passing into your module. You don't have access willy-nilly to everything in JavaScript at this point.
So as a development model in my head, I'm thinking this is more of a functional style approach because you're passing everything into something and then you're just getting an answer out at the end. Is that kind of...
Well, your WebAssembly module can maintain state. So I don't know if I would consider it functional in that way because you are maintaining some state in your memory object.
Okay. Does WebAssembly work on mobile browsers?
It does, yes. One of the nice things about implementing it inside of the VM that's already in browsers is that it makes it relatively easy to turn it on in mobile browsers. So I believe that unfortunately, as part of the mitigation of the Spectre bug, Apple broke their iOS support for WebAssembly. That, I think, is still ongoing, their fix for that. So on iOS devices, WebAssembly is a little wonky right now. But theoretically, there's nothing that holds us back from having WebAssembly across all mobile devices.
Okay. What is the ecosystem like for WebAssembly? What has been compiled to WebAssembly? What is available in WebAssembly?
So right now you have a lot of the early libraries that have been made available are around things like compression, things that are computationally intensive. Mm-hmm. But this is really early days as far as libraries that are being ported to WebAssembly made available. So we're just starting to see things like, as I was mentioning before, the source map library that's used in Webpack and other tools that being written in WebAssembly. And we expect a lot of other libraries like that are widely used as kind of these, more utility libraries to have their performance sensitive parts rewritten in WebAssembly.
So is that another use case for WebAssembly, computationally intensive things, compression, encryption?
Exactly. Yes. You're seeing, for example, a lot of interest from the blockchain folks because that, of course, is computationally intensive. So these computationally intensive tasks, you can just get much better performance from WebAssembly.
I guess data visualization as well, drawing graphs.
Mm-hmm. Yes. Yeah, there was a tool that I think the New York Times released recently that used WebAssembly for some pretty complex data visualization.
Okay, so how long before D3 gets rewritten in WebAssembly?
That is one of the things that we've been talking about. It would be great to see that.
Cool. Is WebAssembly a replacement for something like React Native?
I don't know if it's a replacement for React Native. It could be used by React Native. And I gave a talk last year about what WebAssembly means for React, because you could actually have something like the reconciliation algorithm that is in React rewritten in something like WebAssembly, and then it could be more easily reused across these different projects, but across React and React Native. So I don't think of it as a competitor as much as something that could end up actually powering a project like React Native. And you could even see, I know that the Facebook folks have been working a lot on Reason, which is this language that is more strictly typed. It's based on OCaml. You could see that actually compiling to WebAssembly. That would be a good way for React, because there's also a project that makes it possible to write React code in Reason. You could see that potentially moving React more towards WebAssembly.
I guess I should have asked the question, what is React? Just a quick summary.
So React is it's a framework. It's a JavaScript framework. It makes it possible for you to make web applications. And one of the neat things about it is that it makes it possible for you to say, not here's point A in my app, here, the user has an interaction, you want to get to point B. You don't have to say all of the steps for how you get from point A to point B. You just say, okay, given that the user has done this, I want the app to be in state B now. Here's what state B is. React, you do all of the work to make that happen.
Okay.
And so the reconciliation algorithm that I was talking about before that you could rewrite in WebAssembly, that's what figures out what changes need to be made to go from point A to point B. And it would be possible for you to do that in WebAssembly.
Okay, so the changes that need to be made in the web page or in the DOM.
Exactly.
Okay.
Yeah.
React is Facebook.
Yes, it was created at Facebook, and it powers some of their properties.
Okay, cool. So moving on to how I would develop with WebAssembly. Imagine that I'm a web application developer. How does my day-to-day development change?
So I think that if you're just a web developer, you're not really working on any really performance-sensitive code, your day-to-day isn't going to change very observably. You'll probably start using libraries and noticing that they're getting faster, but you won't actually have to do anything to see that speed improvement. You'll just be downloading the library that you used before, and it will just all of a sudden be faster, but you'll be using the same API to interact with it. That's how we expect WebAssembly to affect most average web developers. If you're working on one of these libraries, if you're working on a React or something like that, then you may need to start incorporating something, languages that compile to WebAssembly into your toolbox. But for most web developers, they won't even need to do anything.
Okay, so imagine that I am working on one of these sensitive applications where I've got a dashboard or something like this, and I need to write stuff in WebAssembly. Mm-hmm. Again, how does I need to incorporate C or C++ into or you said Rust as well. Mm-hmm. Is Rust supported? Rust
is supported. A lot of the work, validating Azam Jas and WebAssembly happened with C and C++ code, so that the toolchain for those two languages is more mature. Rust has just started working on this over the past year, really. So the toolchain isn't quite all the way there, but it is most of the way there at this point.
Could you envision Go?
The Go project is actually currently working on adding WebAssembly support. There's an issue where they're currently working on it. There are a few things that make it slightly trickier for Go, but yeah, I definitely think that Go will be targeting WebAssembly soon.
If I was just working in JavaScript before, I now need to work in JavaScript and let's say C or C++. So I need to think in two languages, think in two ways of thinking.
Correct. Although I think that you might see, because a lot of times when you have those kinds of projects like a React or where an Ember, that kind of thing, you already have division of different modules of different specializations. I think that you'll probably see that these performance sensitive parts, there might already be boundaries between the performance sensitive code and the people that are doing the other parts of the application development, of the framework development. And so it would really be the need for people to learn another language would really be concentrated in those areas. And it might be that you end up just hiring a Rust developer to do that work for you, who doesn't really know JavaScript super well, but who knows how to make who knows the algorithms and stuff that you need to make that stuff really fast. And so that person will then create those modules, because that's the great thing about modules, is they provide you these boundaries that allow you to divide work in this way. That is actually one of the reasons why modules were in the 1970s, why modules were created, was to provide boundaries between people, really. Mm-hmm. So you would have these people that could do the performance sensitive code in a language like Rust, providing an API that then JavaScript developers could use.
But it's really a separate mentality. It's a separate way of working. It's a separate way of thinking.
Yes. Yeah. I mean, it really is. When you're developing a WebAssembly module with Rust, you're really developing a Rust module. that happens to compile to WebAssembly, and that could happen to compile to other stuff too. You can use the same module to compile to multiple targets.
Okay, I'll come on to that as well. I have a question about that later on. Okay, so for the C++, it's kind of a functional thinking again. Is I have a function that I call, and it returns a value or not returns a value. Mm-hmm. It's that sort of, okay, so it's really a separate API, it's a separate module, it's a separate thing.
Yes. Now, one thing is that when it returns a value, you might need to go into its memory to get the data that it's referring to. Okay,
so can I do, one of your interests is how to use Webpack and NPM with the WebAssembly. Could you explain a little bit about what Webpack is?
Sure. Webpack is a bundler. So originally you weren't able to use modules in the browser. There wasn't actually, so you had modules in Node, common JS modules, but you couldn't use them in the browser. And then bundlers came along, and they basically emulated they took some of the runtime that you would have in a project like Node to load modules and emulated that in the browser. So Browserify is an early example of this. Webpack has come along since then. Webpack was developed so that you could break these. What Browserify would do is it would create one huge file that had all of your modules in it. And so it could be slow to load because it needed to parse all of those modules, evaluate them. So Webpack came along to make it easier to split those modules up across different files to do this chunking. So what Webpack gives you is a way to load modules in the browser.
Okay.
Well, we now have a way to do that natively. ES modules have landed. We are actually turning them on in Firefox in our next release. And all of the other browsers also have them on by default. So you'll be able to run these modules natively in the browser. So you might think that you don't need a Webpack anymore because you don't need to have that extra bit of code to run your modules. But Webpack also gives you optimizations. By taking all these modules and putting them into a single file, it makes for less HTTP traffic. So you have, you're waiting for less time for things to download. There are other things that it does. Webpack is probably still going to be used as an optimization for people that are using modules into the foreseeable future. And so we're working with Webpack and with other bundlers to make sure that we can actually emulate this ES module support that we're working on in the community group in those bundlers as well.
Okay, a question that I didn't ask earlier on is how do we get these files into the browser? Is it binary code or is it the actual assembly?
So for WebAssembly, you're downloading a file that has binary code in it. And you're basically just fetching that file. One of the neat things that you can do with WebAssembly is as each chunk of the file is coming in over the network, you can actually start decoding and compiling it as that chunk is coming in. So you can do this thing called streaming compilation. As every line of binary code is coming in, it can be compiled.
Okay, so when you use Webpack, Webpack actually has to understand all of this. Webpack, as I understand it, does three things. It can optimize the code, as in it can cut out bits of JavaScript that it's not using. And if there is a bit of JavaScript that is never going to be called, then it actually, when it bundles up into a single JavaScript, it actually removes that. Is the idea that Webpack would do that as well for WebAssembly?
That's a great question. Actually, just in the past month or so, the maintainer of Webpack has started implementing that for WebAssembly, basically having dead code elimination for WebAssembly as well as JavaScript, yes. So that is one of the things that Webpack would do for you.
How much smaller are the files for WebAssembly than for JavaScript?
It really depends, because sometimes you have code that actually takes more space when you are representing it as simple instructions. So they can potentially be larger, but a lot of times they can also be smaller because binary representation is just much more compact, and WebAssembly was designed to be compact. So it is hard to say exactly. Sometimes it'll be larger, sometimes it'll be smaller, really depending on the code.
So do the performance improvements come from the fact that it doesn't have to parse it on the way in?
There are a few places where the performance improvements come in. So one of them is that decoding. With WebAssembly, you don't actually need to parse, you just decode it. So decoding is a lot faster than parsing, that's true. Compiling, you can do streaming compilation. For us on Firefox, we can actually compile the code faster than it's coming in from the network. So basically, as soon as you finish downloading the bytes, it will have compiled. Also, you only need to compile it once, and a lot of the optimizations that you need have been done on the server side, or before you've gotten the code to the browser. So you don't need to do as much optimization in the browser as you would with JavaScript. With JavaScript, you compile things multiple times. If they get used a lot, you compile them both with a baseline compiler and a optimizing compiler. With WebAssembly, we actually are doing that same work in Firefox. We do have a baseline compiler and an optimizing compiler, but the optimizing compiler is running in the background. Sometimes with JavaScript, you need to recompile if the JavaScript engine made incorrect guesses about how your JavaScript works. Then it will need to recompile the code based on that on the fly. So that's another place where you spend time in JavaScript. And then there's garbage collection, which is only not an issue right now because we don't have garbage collection, but eventually we will have garbage collection.
Okay, so imagine that I'm developing a web application. Okay, I'm using a module that's written in that's using WebAssembly. When I'm debugging, what happens? What can I see in the console? What can I evaluate expressions?
So debugging is currently WebAssembly debugging is kind of an open issue. There is some support for debugging in browsers using the WebAssembly text format, but when you're debugging WebAssembly, you don't really want to be looking directly at that text format. You don't really want to be looking directly at the WebAssembly code. You want to be debugging the source language that you wrote. So if that's Rust, you would want to be looking at Rust code, not the actual WebAssembly that was compiled to.
So then you need the source map.
That's exactly, yeah. Just as JavaScript has minified, you have the minified JavaScript, and then you can use a source map to go from the minified JavaScript back to the pretty JavaScript that you wrote. You use a source map to do that. We have done some experiments around that. We've actually been able to make Rust, make it so that you can debug Rust that actually shows up as Rust code. But through this experimentation, it wasn't clear that source maps will actually give us everything that we need. And this is still an open question that we're working on. It's likely that we're going to need to have more substantial effort across different browsers and different tool vendors to make debugging WebAssembly a good experience. So you can actually find some active work that's happening in the WebAssembly community group in their design repo. And I'll send a link that you can put in the show notes for that.
That's brilliant. Thank you.
Yeah.
So does that mean that I can step over? I can step through,
Yes.
step into?
Yeah.
And
you can, even when you're looking at the WebAssembly text format, you can do that stepping over and you'll see values changing. They're just values that it's hard to ascribe meaning to as a human programmer.
Okay. Yes, because it's just an array buffer, isn't it? It's just an array.
Yeah, you're just seeing, you might be seeing the local values and all of that kind of stuff, but it's really kind of hard to read the WebAssembly text format if it's like reading assembly code. It's extremely difficult to understand what's going on.
Okay, cool. Are there any tools which help you debug and analyze WebAssembly? Are there any static analysis tools?
So yes, there are a number of different tools that people have created for doing various things. For example, eliminating parts of the WebAssembly file that you don't need, that kind of stuff. I don't actually have a great list of them right now, but there are definitely because you can statically analyze WebAssembly, there are tools that have been created. And one of the nice things is that a lot of these tools can work across different language barriers.
Okay. What the place I'm coming from is, okay, so it's C or C++. So imagine that you want to call, you end up calling a system call which wouldn't be available in the browser. On the WebAssembly org site, the demo is actually a Unity 3D app called Tanks. This was exported to WebAssembly. So I would imagine that this was written in C or C++. I don't know if you know that offhand.
I don't know it offhand.
But let's imagine that it was. Does this mean I can have one single source code for the web, for Windows, for Linux, because it's all in C++?
Yes, that is the vision that they started off with was, yes, taking those code bases and just being able to run them on the web without having to do a bunch of extra work.
Okay, so yes, cool. Let's all move to WebAssembly then.
That's what all of the game developers were saying too when they managed to actually get the demo of it working within 2 weeks right before the game development conference.
Oh, cool.
And just seeing that rapid progress, how quickly they were able to get from zero to having something working, having that code working in the browser really wowed the game developers. And they were saying, yes.
Cool. How does WebAssembly impact other languages which are compiled to JavaScript, for instance, ClojureScript, Scala.js, TypeScript?
Right.
Can I change the backend to generate WebAssembly?
That is something that we're actively talking with people right now. So some of the different languages that we've been looking at are Elm would be a good example of a language that could compile to WebAssembly. TypeScript, so one of the reasons why Elm is a good fit is because it has very strict types. TypeScript is a little bit trickier because the types don't, you have some types that don't really map, like number is not really, that's not an integer or a float, that's just a number. So you would need to have maybe like a superset of TypeScript in order to make it possible to compile TypeScript. You need to add some new types to TypeScript in order to make it possible to compile TypeScript to WebAssembly efficiently. But we do think that is possible. Once we get this GC support in there, we think that you could have something like TypeScript that compiles to WebAssembly.
This brings up an interesting question, actually. If you are compiling TypeScript down to WebAssembly, then there's some things that the WebAssembly cannot support. So is there a concept of shims or something like that?
Yes, and so that's the WASM bindgen tool does give you some of that shimming. Host bindings will eventually replace part of that. But yeah, for now, you do have to have some of that in place. This is all, it all depends on the garbage collection proposal, which is still a bit of a ways out. So it's still all just talking about it. We haven't actually, I shouldn't say that. There are people that have experimented with compiling. You'll find a few projects that actually have already attempted doing this kind of compiling TypeScript to WebAssembly. And so you can see how they've done it. But as far as the actual design of how that would eventually work, we're probably still a little bit further out from having that nailed down.
I know Scala.js, for instance, have looked at this. I'm not sure how far they've got. But it's the kind of similar sort of thing that you were saying about Elm, because it's a statically typed language. How mature is the technology? If I write my application in WebAssembly, can I be sure that it'll work next week?
So with the MVP, they basically made guarantees around backwards compatibility. Now, one of the things that they're doing is that may happen is if we do need to make changes that could be backwards compatible, they put a version in the format. So it would be possible to version WebAssembly if we absolutely need to. But the hope is that we won't need to, that we can just make sure that it continues to be backwards compatible from the MVP date, which was last February, through all the way through the future.
Up until 2030, if Java has any experience to go. How portable is it? How much do I need to care about my underlying system, whether or not it be the browser or the operating system?
That is one of the major goals of WebAssembly, is to make it as portable as possible. So ideally, you don't really need to care. Ideally, it would be possible to have a VM on any kind of system that could then take WebAssembly instructions and convert them to whatever they need to be.
Okay. Is there a concept of a polyfill? First of all, could you explain what a polyfill is?
Sure. So a polyfill is when you basically fill in some functionality that a browser doesn't have with code that might run a little bit slower than it would if it were implemented natively. But so, you ship down a JavaScript library that can do what the browser will natively do at some point. So that is what a polyfill is. You can kind of think of Azam Jas as a polyfill for WebAssembly. Right now, if your browser doesn't support WebAssembly, what we recommend is you ship down the Azam Jas version, which will run pretty fast still in Firefox and Chrome. In other browsers didn't ever optimize Azam Jas. I think that Apple is Safari is one of the ones that didn't ever optimize Azam Jas. But because it's just regular JS, it'll still run. It'll just be a little slow.
Okay. Is this a stupid idea? But can you run WebAssembly in Node?
Yes, you can run WebAssembly in Node, and we'll actually be Luke Wagner and I. Luke Wagner is one of the people that pushed WebAssembly forward. He and I will be at the Node Collaborator Summit this summer. That's right around JSConf EU, to talk about how you could use WebAssembly with Node. I mean, there's lots of different options for how you could do this. We've talked with folks on the Node SAS project about how they could use WebAssembly instead of compiling their the underlying libsass to C, or having it written in C and compiling it. So you could have these native modules, which are actually running in WebAssembly instead of native code that you have to compile and then rebuild every single time you have a new version. But currently you can, if you're just using WebAssembly, you can use it in Node just like you can in the browsers, because it's Node's using the V8 engine, which has WebAssembly support.
Okay, so it's using exactly the same thing.
Mm-hmm, exactly.
Okay, so you could get optimizations on a server backend.
Mm-hmm. Yeah, you could write WebAssembly code on a server backend. That's for sure possible.
So that's good if you were doing encryption or compression or something like that.
Exactly,
okay.
Yeah.
Okay, so let's move on to security.
Indeed, yes. Let's move on to security.
How easy is it to introduce security vulnerabilities using WebAssembly?
So fortunately, this is one of the questions that comes up a lot with WebAssembly, because people are worried that it's not secure because they hear that it gives you this low-level access to things like memory. But WebAssembly does some pretty clever things to make sure that it has a lot of the same security characteristics as JavaScript. So basically, like I've mentioned earlier, it's using a lot of the same code. It's running in the same VM. So you have a lot of those same protections.
So you can't access the file system, for instance.
Exactly, right.
You can't access somebody else's another module's memory.
Exactly, because each one of these modules is using its own memory object. And one of the things that WebAssembly does is when you try to access something in that memory object, when you try to pull it out or you try to rewrite it, it will do what's called an array bounds check. It will make sure that you're staying within the bounds of your object. And if you're not, it's going to throw an exception.
You said that I could access JavaScript objects from a module. Can I pass into a module the object from another module, another WebAssembly module?
So could you, with the host bindings proposal, that would be the aim, is that you'd be able to pass these objects around. Now, currently you can't do that. You can only pass in functions.
Okay.
But eventually, yes.
Does the fact that you could be using WebAssembly intermixed with JavaScript make writing more secure code harder? Because you're having to switch paradigms and...
I don't think that the paradigm, I don't think that writing in a different language is really going to change exactly your security mindset, because a lot of the security concerns that you have in JavaScript don't have to do necessarily with JavaScript itself, but with the things that JavaScript is doing. So I think that, a lot of the same security mindset that you would apply to JavaScript would also apply to WebAssembly in the same way.
Okay, but the idea is that there are different possible security vulnerabilities in different languages. So for instance, you never get or you very rarely get a buffer overrun in JavaScript, whereas you would in C or C++ potentially.
Right. So those buffer overflows, those do still apply to WebAssembly. Basically, you within the memory object itself, within your application code, you can potentially have those kinds of security vulnerabilities, but they're not going to have such drastic effects as they would if you were running the code like if you had direct access to memory, because you're just in your own little sandbox, your own little memory object. So if your logic might break, but you're not going to then end up being able to mess with the global object or anything like that.
Okay. How can I guard against binary vulnerabilities? So if I have a JavaScript application, I can look at the source code for the JavaScript application, and it's quite easy to analyze as far as code is concerned. So I can look and see what's happening. Whereas if it's a WebAssembly, then it's very hard to actually analyze and see if there's any problems with it. Are there any mechanisms for guarding against that sort of thing?
Well, at the engine level, we do have some verification. One of the goals was to make it so that the engine could verify that no real shady stuff was happening, that the code wasn't doing some very malicious stuff. Of course, you can still have things that the engine wouldn't recognize, but that are malicious. And those are easier to tell when you are looking at source. That's true. You can actually go from source. There are people who are working on tools that go from the assembly, from WebAssembly back to the source. So you would basically then be able to look at exactly the code that is running in your browser. Somebody recently did this with Rust, where they were able to take this Game Boy emulator in WebAssembly. I don't think had even been written in Rust, but they could basically take the WebAssembly and translate it back to Rust.
Okay, so you could take C++, translate it into WebAssembly, and then translate it back into Rust.
That was my impression from what I saw. I haven't dug into it myself.
Hey, that sounds like a really good solution for changing the language that you compile in. But do you do any signing? Can we do signing of WebAssembly?
There's nothing baked into the WebAssembly spec that does that, but to the extent that you can do it for other resources on the web, you can do it.
Okay, so the future of WebAssembly, where is WebAssembly going? What's next?
So there are some proposals that I've mentioned throughout the podcast that we're really focusing on in the WebAssembly community group. One of them is the support for the ES module API, making it possible to use WebAssembly modules in regular JavaScript ES module graphs. Another is this garbage collection that I was talking about. But basically, we're trying to figure out what the users of WebAssembly beyond games need, because we worked a lot with games in the early development of WebAssembly, but users like Ember, like React, what they would actually need to make it easy to work with WebAssembly in those code bases. And we're putting things into the spec that will help with that.
So you were talking about the MVP. The MVP is actually out now. It's basically working with games. So what's the next MVP, if that makes sense?
So I should make clear that it's not just working with games. It is also like the source maps library that I talked about. That's working well. I would say that the next thing that you'll see, though, is these frameworks. You'll start seeing things like, or also languages. You'll start seeing things like Elm compiling to WebAssembly. And like I mentioned before, Ember already has their bytecode interpreter working in WebAssembly. So you'll see that landing. You'll start seeing this integration more into the web applications that are common to the web.
Okay, and what's the timescale for all of this?
We're hoping that we can have GC over the course of this year. We're really going to work on it. We're going to focus on that. We're hoping that we can have it sooner rather than later. Of course, GC is a really tricky problem, so it is hard to set any deadlines for it, but we are optimistic that we'll make fast progress on it.
Okay, and in your opinion, if I were to start on a web application, would I consider WebAssembly?
I would say right now, you're still probably, it's premature for people that are just working on day-to-day web applications to really be digging into WebAssembly. I'd say that if you're a framework developer, if you're a library developer, for those use cases, it does make sense to start exploring WebAssembly. I would say that for people that are just building applications, I maybe wait.
Well, you have to learn another language for a start.
That's true. So you can get started on learning that other language, and then once we have all of the other stuff in place, you'll have that language in your back pocket.
Okay, so C or C++ or Rust.
Yeah, and I would really recommend Rust for a lot of people. I think that it gives you that memory management security that we were talking about before, without as much of the headache that you have in C or C++. So for people that are web developers, it gives you a little bit of an easier on-ramp to that memory management.
Okay, so this is starting to wrap up now. Is there anything else I should have asked you?
Not that I can think of.
Okay, good. How can listeners find out more about this subject?
So there is the WebAssembly community group repo. You can look there and find a lot of the current design. You can see the proposals that we have going on. I also write a lot about WebAssembly on the Hacks blog for Mozilla. You can take a look at my code cartoon series. I've done a bunch of code cartoons around things like our streaming compiler, what makes WebAssembly fast, how the memory object works, all of that kind of stuff.
Okay. How can people contribute?
I would say contributing to projects that compile to WebAssembly is actually a really good place to start. The Rust WebAssembly effort, the Rust WebAssembly working group, they have a lot of work happening in the repos Rust Lang Nursery /Rust-WASM. I'll send that to you. You can put it in the show notes.
Okay.
But they have a lot of projects for making sure that Rust can compile to WebAssembly well and that WebAssembly can work well with JavaScript. So getting involved in something like that will really help you get your feet wet with WebAssembly, and then you might be able to move on to actually contributing to the community group.
Okay, cool. Well, thank you very much for joining us today, Lynn.
Thank you so much for having me.
This is Matthew Farwell for Software Engineering Radio. Thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.